Hello, this is Graffiti Engineering Inc. team, and we have Sharp Healthcare Santee Medical Office Building a project. So this project is located in city of Santee at the southeast corner of Kayamaka Street and Buena Vista Avenue, right north of 52 Highway. So the purposes of this project are to improve health serve for the city of Santee communities and also to improve coverage for county of San Diego. This project area is 5.4 acres and it has a facility with 19,000 square feet area, and also it has on-site parking lot. So this project include traffic study, hydrology study, structural calculations, and geotechnical evaluation. Traffic study. Traffic study includes road calculations, traffic signal design, design speed, and cost estimating. So traffic study of the project, they're located in the city of Santee, and the impact on Kayamaka Street and Buena Vista Avenue intersection. And this study will help to know the situation of the area for cars movement and average daily traffic. So the roads around the project site are collector, and the area also is plain. So we assume the speed is going to be 40 miles per hour. So we redesign the traffic signal design, and we find that level of service is going to be A by assuming the volumes. So, and also according to the city of Santee, this intersection, I'm talking about Kayamaka Street and Buena Vista Avenue, has level of service A during the AM time and has the level of service B during the PM time. Also, we did sober elevation and horizontal alignment calculation, and also the vertical alignment for the streets around the site location. So for the cost estimation, we have amount around $117,000.
This is the water and sewer study, and this is the project site plan. In water and sewer, we did the following study. To find both average and maximum water demand, the average population is 500% and the average per capita demand is 60 liters per day. Using those numbers, we calculated the average and maximum water demand. The average water demand 30,000 liters per day, and the maximum water demand was calculated using a factor of 1.5, which gives us 45,000 liters per day. Also, both peak hourly consumption and fire demand were calculated as the following: 67,500 liters per day for peak hourly consumption and 716 liter minutes. For fire demand, the largest water demand turned out to be 1,076,040 liters per day. Finally, the study showed that design is compatible with current water sewer limits. Therefore, our recommendation highlights that an upgrade is not required.
Hi, this is Mohammed. I'm going to talk about the structural study of our project. The main objective of this study is to do a structural analysis and design for the medical office building for Sharp in the city of Santee. To fulfill that objective, our report is going to contain some details about the main assumptions regarding all types of loads, finite elements modeling of the building as a whole, and the specifications of the structural materials used to design the building as a whole. To design our building in this project, we relied on using some of the common standards in the industry. For example, we have the ASCE, the American Society of Civil Engineers manual. We use the AISC, which is the American Institute of Steel Construction, and finally the IBC 2015, the International Building Code 2015. For this building, we used two types of materials, which is first the carbon structural steel with the specifications ASTM A3686M and the ASTM A53 and A53M. Also, the second material used in this building is the concrete. For the building of the medical offices building, a compressed cylinder concrete strength is assumed to be equal to 30 megapascal. And in order to properly design the structure of our building, we consider different types of loads. We have the dead and alive loads, wind loads, and the seismic loads. As we can see also, there are some equations that were helpful to determine the loads on the building, depending on the type of the load.
Hello, my name is Keenan Alhabi, and I will be talking in more depth about the structural design. Now, let's talk about the finite element model. The figure that you see in the picture is a full 3D analysis model that is developed to model the building that we are using for this analysis. We are using the software ETABS. ETABS 3D model. The building member forces are computed and designed. The columns and the main beams and secondary beams are modeled as frame elements. Floor deck and roof sheets are modeled as deck elements. Now let's talk about our design of beams of typical floors. As have been mentioned before, we have used the E-tabs for our design. We also use the AutoCAD as well. Now from the picture that you see on the left, this is actually an illustration that shows the ratio between the actual stress and the allowable stress. And from the picture that you see on the right, this is actually our foundation design, which have we extracted from our E-tabs. Lastly, for the structural design, we have included some cost estimation. Now, from the table that you have in the picture, you will see that we have tried to include everything for our structural design cost estimation. We have included materials plus the labors and how much would the whole structural design cost. We have came up to a total cost of $123,703.
For the geotechnical design study, we computed the natural disaster in San Diego County. Comparison to the other county, San Diego actually has very high chances of getting natural disaster. If you look clearly in the map, you can see the San Diego area is mostly red. That means that San Diego has a higher chance to get natural disaster. By knowing that, in the calculation, we designed to put the footing and walls and pile to strengthen the foundation of the building. So on the next slide, it's the soil type around the site. So if you look closely to the map on the left, you can see there's a red dot in the middle. That's the point where our medical center is located at. So it shows that all the soil type around the map. So with the soil type, we can calculate the phi and the strength of the soil, so we can compute and calculate the footing size and shallow foundation design. For the cost estimation of geotechnical design, we included the lab testing and the outside field testing. So the outside field testing, which is the soil and civil testing, we have field testing, soil investigation, and penetration tests. So we use the CPT cone test to test the soil type, and then we do the calculation. For the lab testing, after we've done the outside or site testing, we take the sample and then we test it in the lab. So include the natural moisture content, specific gravity, and bulk density test, safe analysis of fine and coarse aggregates. And the total cost of geotechnical design is $107,000.